Hi ladies and gents, Mary here, and I am going to try and provide a little extra trig practice for some students. Some people have reached out to me indicating that trigonometry is kind of challenging. It's been a long time, or they've never had any trig, and we do use this a lot in physics. So all we're going to work with in this course is right angle trigonometry. So there's always going to be a right angle somewhere involved. And I think the biggest challenge most people have is, then the question I get the most often is, how do I choose the right function? How do I choose sine, cosine, or tangent? And that is always tricky. I've had so many students through the years who've said, I can do the math, but I just don't know which equation to use. So we're going to go through a couple examples, and I hope this helps. So let's say I've got a triangle like this, and I know that this angle is 30 degrees. And I know that this side is 10 whatevers, meters, newtons, whatever. And let's say I want to find the length of this side. I'm going to call it h because it's the hypotenuse. Now, when I look at this, the first thing you've got to do before you choose a trig function is you have to choose the angle that you're going to work with. And often you're only given one angle, and so that should make it easier. The angle that I'm dealing with here is 30 degrees. It's not going to ever be the 90-degree angle. And the side that is the long side of the triangle, that's always going to be your hypotenuse. The side that is next to the angle, that will be your adjacent. And the side that does not touch the angle at all, that's going to be the opposite. Now, the trig functions, sine, cosine, and tangent, here are the equations. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, if you want to take this very carefully and systematically, here's what I recommend that you do. That you say, okay, I know that the adjacent side is 10. I know the angle is 30. And what am I looking for? What am I after in this problem? We started out saying, what is the long side, the hypotenuse? And I would write them all down like this. Now, yes, this is going to take another moment of your life, but it's easier than being frustrated. And once you have this written down, adjacent, the angle, and hypotenuse, now you can choose the formula that contains adjacent and hypotenuse. Well, tangent is opposite and adjacent, so it's not that one. Cosine is adjacent and hypotenuse, so this is the one. This is the winner for this problem. So the cosine of the angle, cosine of the angle is going to be the adjacent over the hypotenuse. And there's a couple different ways you can do it. You can put the numbers in right away, which most students like. Most instructors want you to do the algebra first. So I'll do it your way. So I'm going to say the cosine of 30 degrees, that symbol, that theta symbol, represents that angle. The cosine of 30 degrees is the adjacent, and the adjacent we know is 10, divided by the hypotenuse. Now we need to do some algebra. And the algebra is going to be, I'm solving for the hypotenuse. Well, it's down below. In order to solve for hypotenuse, I have to get it up on top. So how do I do this? If you multiply both sides of an equation by the same thing, that is going to make it simpler. So these two are going to cancel. I now have the hypotenuse times the cosine of 30 equals 10. I'm still not there yet because I've got to get the hypotenuse all by itself. So how do I get the hypotenuse alone? I'm going to divide both sides by the cosine of 30, divide by the cosine of 30. So my hypotenuse will be equal to 10 divided by the cosine of 30. And if you put that into your calculator, 10 divided by cosine 30, whoops, I hit the wrong button. 10 divided by cosine 30, I got 11.5 if I stick to 3 significant digits. Okay, that's one. Now let's do another one. Let's do another triangle. Let's say, here's my triangle. Let's say I have this angle, and I know this angle is 60, And let's say I know that this side is 7, and I want to find this side. I'm going to call that side x. So first thing I've got to do is look at identifying all of my sides. So this is the angle I'm going to work with. The long side is always going to be the hypotenuse. The side next to the angle is the adjacent. The sine opposite the angle is going to be the opposite. And notice that this line does not touch either one of the lines that touch the angle. So the opposite is opposite that angle on the triangle. All right, now what do I know? I am going to try and find this. This is my unknown. So opposite equals question mark. I know my angle is 60 degrees, and I know my adjacent is 7. So I'm going to have to choose a trig function that contains opposite and adjacent. So I'm going to go back to my equations, and my equations say I want one that says opposite and adjacent. Now I have the angles, so all of them contain the angles. Which one contains opposite and adjacent? Well, this is opposite and hypotenuse, so it's not that. Adjacent hypotenuse, not that. Opposite and adjacent, so this is the one. Tangent is the one I'm going to use this time. So tangent of theta is going to be opposite divided by adjacent. And this time I'm going to do the algebra first just because I can. I'm solving for the opposite side. That's the thing I want to find. So to do that, I've got to get this alone on one side of the equation. I'm going to multiply both sides by adjacent. That will cancel adjacent, and I'm just going to flip them. So I'm going to put opposite on this side is going to be equal to tangent times adjacent, tangent of the angle times the adjacent side. So the opposite, which is what I want, is going to be equal to the tangent of 60 degrees. I'm going to put my numbers in, times my adjacent of 7. Now pick up your calculator, do this with me, hit tangent of 60 times 7, and I get that the opposite side is 12.1 if I'm sticking to 3 significant digits. Okay, I hope that helps. Now let's do one more thing, and that's breaking vectors into components. That can be frustrating as well. So let's say we've got this. Let's say I've got a vector that is at an angle of 40 degrees. The length of this vector is 200, and I want to know how much this side is going to be. I want to know how much up it's going to be. Well, all I have is this one vector, but I'm going to make a triangle out of it. Here's my angle, here's my 90-degree angle, and I'm going to make a triangle out of it. And what I want to find is this up part. Okay, same process we did before. Identify your angle, name the sides. All right, hit pause, name all the sides, opposite, adjacent, and hypotenuse. Okay, did you do that? So the long side, this is your hypotenuse. The side next to the 40, what's its name? Adjacent. The side opposite it that doesn't touch the angle, this is the opposite. Now, what are we going to try and find? Well, we want this upside. This is the opposite side. So opposite is my question mark. Adjacent, I don't know, and I'm going to get him out of the equation because I don't care. Hypotenuse is 200, and the angle is 40. Now, here's one of the ways that I do this with sine, cosine, and tangent. There's the old memory device called Sohcahtoa, and I do this all the time. If I'm trying to choose my right trig functions, because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sohcahtoa is a little memory aid that helps humans remember these equations. And I will very often, I'll write this all out and I'll put a little space between them, remembering that each one is an equation. And then I'll look at what variables I have and say, okay, I know hypotenuse, so I've got to pick one of these that contains hypotenuse. Well, that's this one or this one. Tangent does not contain hypotenuse. There's no h, so that's not it. I also need one of these that contains opposite, because opposite's what I'm looking for. Opposite's an O. That's going to be this one, not that one. So the equation I'm going to use for this is going to be sine. So sine of theta is the opposite over the hypotenuse. I'm going to have to give myself a little bit more space to work here. So the sine of 40 degrees is going to be the opposite, which I'm solving for, and the hypotenuse was 200. Now, how do I get my opposite alone on one side of the equation? In order to get this alone, I have to get rid of the 200. If you do something on one side of an equation, you do the same thing on the other side. 200 will cancel, and I'm just going to flip these around because my brain, I always like the thing I'm solving for on the left. So the opposite side, that's the side I'm solving for, is going to be the sine of 40 degrees times 200. So I'm going to pick up my calculator. I'm going to do sine 40 times 200, and I ended up with, if I round this off to 3 sig figs, 129, and that is going to be the size of this component of this triangle. I hope this helps. If you're still confused, please contact me. And doing math at a distance can be challenging, and so you got to keep communicating, and we'll figure this out. All right, you guys, have a grand day. Bye-bye.